In this video, we are going to find the basic operations of matrices. Let's find the matrix addition and matrix subtraction. You can add or subtract two matrices only when the two matrices are of the same size. So when the two matrices are of the same size, you can add or subtract the corresponding elements of the two matrices. For example, if I have A, B, C, D, E, F, U, V, W, X, Y, Z, then I can add the two matrices are equal only when the corresponding elements are equal. So the sum and difference of these two matrices will be of the same size. So if it is 2 by 2, then the sum and difference also will be 2 by 2. If it is 2 by 3, then the sum and difference also will be of 2 by 3. So addition is not defined for matrices of different sizes. Only when they are of the same size, you can add or subtract the matrices. Now in order to add the two matrices, we add the corresponding elements A plus W as well as B and X, C and Y, D and Z are added. The same way for a subtraction also. So here 2 plus 3, negative 3 plus 2, etc. So the corresponding elements are added. In the third case, the first one is 3 rows and 2 columns, 3 by 2 matrix. The other one is 2 rows and 3 columns. So since they are of different size, different order, you cannot add or you cannot subtract these two matrices. So matrix addition is not possible for C. In this case, you can easily add the two matrices. You can add the two matrices using graphing calculator also. So in this case, you have to enter the first two matrices A and B. Then as usual, you add A plus B. That will give you 5, negative 1, 7, negative 1, 5, negative 7. We can use the graphing calculator to get the addition or subtraction. Matrix, under the matrix properties, we know that since you can add or subtract the matrices only when they are of the same order, and addition is commutative. So since you are going to add the corresponding elements, A plus B will be B plus A. That is, matrix addition is commutative. But matrix difference is not commutative. A minus B will not be B minus A. It is associative. A plus B plus C will be A plus B plus C. We know that a matrix is called a zero matrix if all the elements are zero. It can be of any order. It can be 1 by 2, 1 by 3, 2 by 2, 2 by 3, 4 by 4, any order. But every element in that matrix will be 0. Negative of a matrix, if a matrix A is given or M is given, negative of the matrix is obtained by changing the sign of each element in that matrix. So if two matrices are given, and if there is an equation, if there is an equality, you have two expressions, one on the right hand side, one on the left hand side. The left hand side is a difference between two matrices, so you can subtract the two matrices first, and that is equal to 4, 3, negative 3, 2. So each element will be equal. A minus 2 is 4, B plus 2 is 3, C plus 1 is negative 3, and D minus 4 is 2. So you can get the value for A, B, C, and D from this. Multiplying by a constant. You can multiply a matrix by a constant like negative 3. When you're multiplying by a constant, each element of this, each entry will be multiplied by that constant, negative 3 in this case. So your ultimate answer will be negative 6, negative 15, 0, 9, negative 3, 6, negative 18, 3, and 12. You can use matrix addition, subtraction in word problems. So here there are two different sales, one for August and the other one for September, for these two persons, Ms. Smith and Mr. juries. If we are trying to find the combined sales, we have to add them together, A plus B, and that will be the combined sale. And if we're trying to find the commission for this, then 5% of that is a commission. 5% of that will be 0.05 times B, and that is the answer. You can also find the product of two matrices. Now I have given an example where I'm trying to find a matrix of 1 by n, 1 row, n column. The other one is n row and 1 column. You can multiply two matrices only when the number of columns of the first one is the same as number of rows of the second one. In this case, number of columns of the first one is n, number of rows of the second one is also n, and hence the matrix product is applicable, whereas the resultant will be that extreme 1 by 1. So that is shown here. The corresponding elements are A1, B1 plus A2, B2 plus etc. A and Bn are added. The number of elements in the row matrix and the number of columns, rows in the thing must be the product. Now if I have a row matrix and column matrix, again I take each row multiplied by each element here and add them up. So here it is 1 by 4, 1 row and 4 columns. It is 4 row and 1 column, so ultimately it must be 1 by 1. So it will be just a singleton set, element with just single element 32. So if you have a matrix of M by P and P by N, then ultimately, see here the number of columns is the same as number of rows, so product is possible, multiplication is possible, the ultimate final result will be of order M by N. If they does not match, if this number of columns of A is not the same as if P here and S there, then the multiplication is not defined. So you can also find whether the matrices are of the form A by B, B by C and all that, and check whether the product exists or not. If I have two matrices, the first one is 2 by 3, the second one is 3 by 2. So ultimately I must get it as 2 by 2. So each element here can be multiplied. So expanding through the first row, first column element, first row, second column element, second row, first column element, second row, second column element. So simplifying this, you can get the result. But in this case, AB is possible, but BA is not possible because B has got 3 rows and 2 columns. The other one is 2 rows and 3 columns. So this BA is not possible. AB and BA are not equal, in which case the product is not commutative. So here again you can find the value for AB by multiplying the corresponding elements, or CD by multiplying the corresponding elements, and C squared by multiplying the same matrix twice. But there is no matrix division. There is no defined process of dividing a matrix by another matrix. We use another technique called inverse of a matrix, but there is no matrix division. So this video helped us to understand the basic operations in matrices, especially addition, subtraction, multiplication, and division. There is no division. Multiplication is not commutative. Multiplication is positive only, is allowed only when the number of columns of the first matrix is the same as number of rows of the second matrix. Addition or subtraction is allowed only when the order of the two matrices are the same. You can also equate the two matrices provided that the order of the two matrices are same. And you can either use your graphing calculator to get it, or you can do it manually. So this video helped us to understand all the different basic properties of matrices. Hope this was helpful. Thank you for watching and thank you for listening.